Class, as you can tell from the last couple of slides, next thing we're going to talk about is levers. A lever, as you saw in the previous slide definition, is a rigid or semi-rigid body when subjected to a force whose line of action does not pass through it. Its pivot point exerts force on any object impeding its tendency to rotate. We have three different types of levers. We have a first-class lever, second-class lever, third-class lever. The difference between all three levers is what we're about to go over, and it basically has to do with the resistance force, the muscular force, and the location of the fulcrum. Fulcrum in this slide right here is our pivot point right here. The fulcrum is a pivot point. In a first-class lever, we have a resistance force, classified RF, and we're going to say that's like a 40-pound dumbbell. Can be gravity, can be inertia. And then on the opposite side of the fulcrum, over here, we have our muscle force. So it goes resistance force, fulcrum, muscle force. Now in order for this to stay balanced, this also needs to be 40 pounds. As mentioned, the resistance force can be gravity, inertia. Right here it's our 40-pound dumbbell, and it's a force generated by a source external to the body. The muscle force is a force generated by biochemical activity or the stretching of non-contractile tissue. This draws opposite ends of a muscle toward each other. Each of these forces have a moment arm. The moment arm is the perpendicular distance from the line of action of the force to the fulcrum. It is indefinitely long. So if my resistance force is right here, the moment arm for the resistance force is this distance, and it's infinitely long going this way. The moment arm is also perpendicular to the force. Perpendicular, 90-degree angle. This is the moment arm for the resistance force. The same thing applies to the muscle force. So this has a resistant arm, stopping right there at the fulcrum, infinitely long going in the opposite direction. Once again, it's perpendicular. Purpose of knowing what about the moment arms. These create a mechanical advantage. In this diagram right here, these moment arms are approximately equal. Therefore, there's no mechanical advantage. The mechanical advantage goes to whoever has the longest moment arm. So if I were to adjust this picture and say move my resistance force to right there, now resistance is right here. This distance is a lot shorter than this distance. My muscles have an advantage, longer moment arm. The exact opposite can be said if I were to have the resistance force out here and the muscle force stops here. Since the resistance has a longer moment arm, there's a mechanical advantage. The importance of moment arms before we get on to first, second, third class, or the second and third class lever. Moment arms are going to change when you change up an exercise. I'll give you an example, and we're going to go over this. I'm going to video this later in the school year. A squat. We have back squats, we have front squats. Back squat, the bar goes on our back. Usually our hips go back. We tend to bend at the waist. And so in the bottom position, our shoulders and the barbell would be our resistance force, are somewhere right above our kneecap. This creates a very, very, very short moment arm for the quadriceps, but it increases the moment arm for our hamstrings and glutes. Therefore, a back squat is very, very beneficial for the hamstrings and glutes. Front squat, you have to keep your torso a little more vertical. Therefore, bottom position, the weight is closer to the hips. This shortens the moment arm for the hip extensors or glutes and hamstrings and lengthens it for the quads, knee extensor, so it's a better exercise for the quads. That has to do with all type of levers of the moment arm and mechanical advantage. This was our first class lever. Next, we're going to go over a second class lever. Let me erase this right now. So now we're on second class lever. The difference between a second class and first class lever, and a lot of the muscles in the body, they're going to act as second or third class levers. First class lever, the book shows you a tricep extension. Tricep extension. I'm going to argue once you see a couple more of these pictures that might not be the best diagram for a first class lever, because they start talking about the wrist when really the tricep exercise, the hinge joint or the fulcrum would be the elbow. So first class lever, there's not many in the body, but a second class lever, when you're thinking of a second class lever, it's a lever for which the muscle force and resistance force act on the same side of the fulcrum. The muscle force has a longer moment arm. So second class lever, muscle force, be right here. Same side of the fulcrum. Here's our resistance force. That's a second class lever. Third class lever, we're going to change the muscle force and the resistance force. So now the resistance force has a longer moment arm because we're right here, and the muscle force has a shorter moment arm. Next couple of slides, you will see diagrams of second and third class levers.